Hey everybody, let's do the front page of this Conservation of Energy and Work Concepts page here, part one. So in this case here, if we look at it, we've got a ball on top of this peg here. It says it's got a mass of 2 kilograms. They tell us that the potential energy up here is 100 joules. So as it falls, the potential will convert into kinetic. Right here on the ground, it's basically got 0 joules of potential energy, which means all 100 joules of that have been converted into kinetic energy. So now they want us to find, let's say, the velocity. So in order to do that, well, we know that kinetic energy is 1/2 times mass times velocity squared. We know that kinetic energy is 100 joules, and we know that the mass from here is 2 kilograms. So this 1/2 times the 2 will cancel. And then basically 100 equals v squared, or v equals the square root of 100, so that is 10 meters per second there. They say what forces are doing work? Well, the force that pulls it down is gravity. And so this stands for the total mechanical energy. Is the total mechanical energy conserved? Yes. And the explanation is gravity is an internal, let me just write that word here, internal force. So if gravity is in the system and it's considered an internal force, then there is no external work done in this equation. So our initial total amount of mechanical energy has got to be equal to our total amount of final mechanical energy there. So on this one over here, it's exactly the same thing. The potential energy is 100 up here. It's going to be 0 here, which means the kinetic energy is back to 100, which if we solve for it there again, then it will also give us 10 meters per second. And all these answers are exactly the same on this side as they are on that side. So let's do the second problem on the front here, and then that's what we'll end this video, and there'll be a second part for the second page. Here we have a 2 kilogram ball again, and it's swinging on a pendulum. And so it starts up here at this height indicated by the dashed line. And again, it's important to realize that it is 2 kilograms. And so first thing that's easy to realize is that up here we've got 10 joules of potential and 0 kinetic. So we have a total of 10 by adding those together. That means we always have to have a total of 10 through all of these. So here we have 2 joules of potential, so the other 8 joules must be kinetic. Here we have 0 potential, so all 10 joules must be kinetic. And then back here, we get back to the same height that we were before, so our potential energy must be the same at 10 joules, which means our kinetic energies must be back to 0 joules. Plus, they say 0 velocity here. So now let's find the amount of height or velocity, as the case may be. So to find the height, we're going to use the gravitational potential energy equation. Gravitational potential energy is mass times gravity times height. I'm actually going to rearrange this because we're going to do it a couple times. I'm going to get myself an equation for height. So to get the height, I would divide each side by mg. So I'll get the gravitational potential energy divided by mg. That will give me the height there. So we can plug that in for this one. To find the height here, well, we have 10 joules of potential energy. The mass is 2 kilograms from up here, and gravity is 10. So these 10s will cancel, and you get a half, or let me write it right here, 0.5 meters. By the way, we've already said this is the same amount of potential energy here, so this must also be 0.5 meters. What about right here, where we have 2 joules of potential energy? We'll plug it back into this equation right here. Once again, our height is going to be our potential energy, which is 2, over our mass, which is 2 times 10. The 2's will cancel, and we get 1 over a 10, which is 0.1 meters. Here we have 0 potential energy, so we must have 0 height. Now for the velocities. To solve for the velocities, let's sort of divide this page up. We're going to use the kinetic energy equation. Kinetic energy is 1/2 mv squared. So here we don't have any kinetic energy and no velocity. Same thing on this end. But over here we get 8 joules of kinetic energy. So let's plug that in there. 8 equals 1/2. The mass is 2. And we're solving for the velocity. This half and the 2 will cancel, so v will be equal to the square root of 8, which is about, square root of 8 is about 2.4, I believe. Yeah, right around there. And so then let's do the same thing to find the kinetic energy on this one. The difference is our kinetic energy is 10 this time instead of 8. So 10 equals 1/2 times the mass, which is 2, times v squared. those will cancel, and so v will equal the square root of 10, which will be about 3.16 around there meters per second.